Warning: the following podcast delves deep into technical architectures, advanced coding patterns, and production-grade AI. Prepare to upgrade your understanding of agentic AI.
This week on the Agent Factory.
So I've been hearing a lot of buzz about this new concept of software 3.0.
But there is one more. It's the dynamic with swarm pattern.
Speaking of context, there's now this new term of context engineering that's going around. Hi everyone, welcome to the Agent Factory, the podcast that goes beyond the hype and dives into building production-ready AI agents for agent developers. I'm Shir Lador.
And I'm Vlad Kolesnikov. I'm actually very excited to join the podcast. And today we're talking about a topic that is getting a lot of traction: multi-agent systems.
That's right. It's a huge topic, and it can be a bit confusing. By the end of this episode, you'll have a solid understanding of why and when you should consider using multiple agents instead of one, the key architectural patterns for multi-agent systems, and the practical trade-offs of each pattern.
And you'll be better equipped to design more capable and resilient agentic systems for your next project.
We're excited to get into it. So if you enjoy the show, please subscribe to our YouTube channel, follow us on your favorite podcast platform, and engage with us in the comments or on social media using the hashtag #TheAgentFactory. Let's get started.
First up, let's check the agent industry polls. What's new this week, Shir?
So there's a lot of buzz about this new concept of software 3.0. Andrej Karpathy just gave a talk about how we used to be in software 1.0, where we did traditional coding, and then we transitioned to 2.0, where we train neural networks, and now we are at 3.0. This is a new era where we program natural language prompts, and LLM is like the new operating system.
Yeah, it's really a big paradigm shift that we are going through. We're moving away from, making those explicit instructions and coding computers to more like defining goals, providing that context, creating a vibe, and letting the agent figure out the how part.
Yeah, and speaking of context, there's now this new term of context engineering that's going around, basically acknowledging that prompt engineering is just one piece of the puzzle. And the bottleneck is not the model's intelligence, but it's how to manage that limited context window.
Yeah, LLM now, what they call CPU, and this context window is RAM. Kind of very precious, limited, temporary workspace that extremely important.
Yeah, and for our listeners, the diagram on the screen shows this flow where you have different types of context coming in. The user input, files or documents, and the tools output. All of those are competing for that limited space in the context window. And the context engineering is basically the art of getting the right information at the right time.
Yeah, and within that, they use three core strategies: isolating, persisting, and compressing.
Yeah, and if you're talking about isolation, what it means is instead of passing the entire context, you choose the data and the schema to pass to each of the sub-agents. So this way you can cut noise and avoid distracting the LLM with irrelevant information. And I actually saw a video yesterday that demonstrated exactly that with LangGraph.
Oh, I know. That video is a nice watch. Let's make sure we link it in the show notes.
Yeah.
The video also demonstrates the other strategy that I mentioned, which is persistence, a way to leverage past conversations.
Yeah, so you can retrieve memories based on the relevance and the recency for that agent. And that would help the agent focus on them by removing all irrelevant information.
Yeah, and speaking about removing relevant information, the third concept they use is context compression. They use summarization to shorten the context in general, to kind of summarize it. They extract important facts and only use them in the downstream steps.
Yeah, so to summarize, we're moving away from focusing on how to design the perfect prompt to designing a more sophisticated runtime architecture around the model. And with that, let's shift to another news. Google just released a new tool for developers who live in the terminal, the Gemini CLI.
Oh, yeah. It basically brings the power of Gemini directly to your command line. And with that, Gemini can understand your code base, fix bugs for you, and even help with the complex Git commands. I need that definitely.
Yeah, you know what, Vlad? I've been playing around with it, and I actually saw it's very helpful for non-coding tasks, like creating a slide deck from a document or organizing the photos from your last trip or even implementing a whole YouTube tutorial for you.
Yeah, and if you think about it, it can connect to your local tools. It can use MCP servers with a lot of features. Yeah, and that really just drives to infinity the number of capabilities that Gemini gives you through the CLI tool. It also, speaking about our current topic, it's a perfect example of a specialized agent.
Yeah. And now, finally, let's get to news that are very relevant to our main topic today, multi-agent systems. So Google just donated the A2A or agent-to-agent protocol to the Linux Foundation, which is a huge step towards creating a standard open way for AI agents to communicate with each other, regardless of who built them.
Yeah, it's really all about interoperability. Funny word, huh? Red Hat and Google just recently released the new A2A sample. We need more of those. And that sample features Python and Java agents. I think they built one Python agent with LangChain, classic. They built another agent which is based on Java using LangChain for J. And then obviously we cannot go anywhere without ADK. They built another agent using ADK in Python. And all of those, they talk to each other. I know they use MCP servers, but the communication happens through A2A.
Nice. I love how Java and Python are playing along nicely.
Yeah, that doesn't happen often, right?
Yeah. And to help developers debug those A2A servers, we now have the A2A Inspector. That's a new web-based open source tool that lets you debug servers and implement the A2A protocol.
Yeah, I know. I'm currently working on an A2A agent, and I find this tool extremely useful for debugging and understanding what's going inside those conversations.
And that's a perfect transition to our main topic, Vlad. Are you ready to get down to the factory floor?
Definitely. Let's go.
Welcome to the factory floor. Today, we're getting into multi-agent systems.
In your last episode, remember, you and Ivan touched on this when you discussed the LangChain benchmark. It showed that as you add more complexity and tools into a single agent system, they start to struggle, while the multi-agent systems maintain much stronger performance and resiliency.
Yeah, I really like the finding from that paper that basically single agent systems start to drop in performance as you add more tools or domains to the problem. And basically the agent gets overwhelmed, like any of us would get overwhelmed with adding more skills and more domains. And it's also related to the context engineering concept we just discussed. Yeah.
Yeah. So in their tests, they noticed that multi-agent architectures they tested are far more resilient and they deal better with complexity of the problems and just with the amount of tools and sub-agents they have. So for any complex and real-world problem, just single agent trying to do everything, doing multiple jobs is not really the answer.
Yeah, so let's talk about the question of questions I've been wondering about. When do you want to stick with a single agent, and when do you identify this is the right time to move to a multi-agent system? So if we're talking about a single agent, you can see in the visual that it is powered by one LLM for everything, for reasoning, planning, and actions. And this is basically the simplest architecture for agents.
Yeah. If you think about it, the single agent is good for doing a single task. You have like one profession, one job, you do that job and you're great at it. When you start making the agent do multiple jobs, this is where it doesn't go that great.
Yeah, it struggles there. So that's what the LangChain benchmark showed, that their performance dropped with the complexity. So I'm thinking about the simple rule of thumb that when a task needs multiple distinct skills, maybe we need to stop giving that single agent more work and actually create a team.
Yeah, and that team is your multi-agent system. You know how in real world you hire a researcher who drinks coffee and reads all day, and you also have a coder who hasn't seen the sun in weeks. Yeah, and each one is a specialist, and they do what they're good at.
Yeah, and you can also earn, if you like, built-in quality control. You can have one agent whose sole job is like to look over the other agent's shoulder and say, "Are you sure about that?"
Yeah.
Which could be very helpful from stopping them make stuff up.
Yeah, let's assume you decided to go with multi-agent system. Now, the next kind of logical question is what to use to structure it, what strategies we have, what patterns. And industry over time, despite being very young, actually, already identified several common patterns. And the image on the screen currently shows them.
Yeah, so the first category you see on the screen is with supervisor. So a supervisor, basically, as you can think about like a traditional org chart, you have a manager or supervisor that coordinate the tasks and delegate them to each of the specific specialized worker agents.
Yeah, now let's take the router supervisor pattern. It's on the left. In that pattern, the supervisor agent, that kind of coordinator, talks to worker agent one by one. And it's a great pattern when you pass information from one agent to another. So basically, the agent does something, gives you the info, you take that info, and not necessarily in a original way, pass it to another agent, and you sort of like interact with your team one by one. You understand this is not a predefined sequence. For example, let's take a situation when we have a supervisor agent and it's giving a research task so for the user, it is a research agent. However, it actually has a team of two sub-agents. One is the research agent, the one that crawls around and finds the information, and another one is a writer agent that summarizes information. So it kind of starts with your main coordinator supervisor agent asking the research agent to gather information, then pass that info to the writer, and then the writer creates a summary. Depending on how the conversation is going, you may ask the writer to make changes in the summary because you didn't like something.
Yeah, so what's interesting to notice there is that it doesn't go through the exact same order every time, right? It adapts to the specific situation, which what makes it agentic. And another pattern is the parallel or supervisor agent that delegate tasks that can be run at the same time. And this is great for speeding things up when possible.
Yeah, let's think about an example. Let's say you create a market research agent, or like a market analyst agent. The first thing your supervisor agent need to do is to ask something, let's call it a data agent, to pull sales figures, like you have your sales data. Next, we want to get last news. So the supervisor will ask news agent to summarize the recent press, and the social media agent to get public sentiment, all at the same time.
Yeah, I think the main challenge with this kind of architecture that we sometimes see is that the supervisor may stop sending the critical information to the other agents. You can call it compartmentalization. And this connects also to the concept of context engineering, which we just talked about, in which we can intentionally control the context each sub-agent receives.
Yeah, I had to deal with that myself. Now, let's move on to the second part, the deterministic flows. Here we see patterns like sequential and circular flow. And in the sequential flow, agents operate one after another, in the predefined sequence. They do the work, they generate the info, and that info is passed to the next agent in line, basically like an assembly line.
Yeah, and the next pattern is also very similar. That's the circular flow. That allows for iterative refinement. For example, you can have an agent who's a coder and an agent who's a tester. And then the coder will pass the code to the tester. If the test fails, the agent coder will get it back, rewrite the code. And this goes again and again until the tests are passed.
Yeah, and those deterministic patterns, it's very close to traditional programming when you just say, I want to run this agent in this sequence, I know exactly what to do. And in the real world, if I think of the agents that I developed so far, it's more like a combination of those. But the one pattern that I personally haven't used is this dynamic or swarm pattern. And it's really different from what I'm used to. Because it's a all-to-all communication model when things may get a bit interesting and sometimes chaotic.
Yeah. So how do you think that differs from the supervisor model we just talked about?
Yeah, the real difference, if you think about it, is the control versus collaboration. In the supervisor model, you have a clear boss giving orders, and it kind of makes the process more predictable, but also, and we discussed it many times so far, potentially creates a bottleneck, right? You may end up situation when the information is not passed correctly or just held up.
Yeah.
With that, the upside, a clear upside of a swarm is the flexibility. If one agent gets stuck, another can sort of like jump in to help. And that's how ultimately all human teams that are effective work together.
Yeah, so I could think about the downside of this, which is potential chaos. Like a group chat with no admin. You ask for something like a report and they end up arguing about Python libraries and ordering pizza.
Yeah, that's what we do, right?
Yeah.
Yeah, in that situation, you're basically less of a manager and more of a babysitter for brilliant, but very distractible interns.
Yeah. So just to summarize about Swarm, to make it work right, it requires very careful design to ensure those agents stay on track. And each pattern we saw has its trade-offs in terms of control and speed and complexity. And it depends on the problem you're trying to solve. What pattern should you choose?
Yeah. Just to make it more concrete, I've actually built a small multi-agent system that demonstrates my favorite router supervisor pattern. Let me show it to you. Here's my little data engineering agent, which actually has 4 different agents. One is the orchestrator or router, like we talked about before, and 3 specialized agents, business analyst, data engineer, and BI engineer, each doing their respective task with the uber goal of answering business questions based on the data in BigQuery. Now, if I launch my engine and ask, show me our lead conversion trends, it starts with business analyst, how expected, and business analyst analyzes the question, gives it interpretations, multiple ways of solving the problem, and then once that is crafted, it passes the information to data engineer, who's expected to construct a SQL query to retrieve the data for analysis. Once that part is done, the data goes to BI engineer. That would be our next logical step, and the BI engineer builds a chart, right? It does that part of the business intelligence job. And at the end, I may actually not like the way it's presented, so I ask it to make a line chart instead.
Yeah, and look, it goes directly to the BI engineer and only asks it to change the chart without getting the business analyst and the data engineer involved. I think that's a nice demonstration of the dynamic nature of this agentic router system.
Yep, that's perfect.
All right, now it's time to answer a question from the developer community. Keep them coming, folks.
This week's question comes from a developer on X who asks, I'm building a multi-agent system using the supervisor pattern. Okay, just like myself. It's all manageable when I run my agent locally. Great. Hopefully you do it with ADK Web, right? But getting visibility into what delegations were made, for what reason, and what tools caused what is really hard when you don't run your agent locally and instead do it in the cloud. Any advice on how to make it easier?
Yeah, I can so relate to that question. Debugging those systems once it's deployed on the cloud is one of the biggest challenges. And I think the key here is observability. You need to log and trace every single decision point.
Yeah, exactly. It means that you log the incoming tasks, how the LLM breaks it down to subtasks, which worker agent it delegates each subtask to, and why. And you should explicitly have the supervisor output its reasoning for choosing a specific worker, so you have better visibility into it.
Yeah, and there are different services and tools and libraries that can help you log and observe those signals. On Google Cloud, for example, we have services like cloud monitoring. We have libraries like Open Telemetry that you can use, or even framework-specific integrations like the one we have in ADK. Vlad, do you want to show us what that looks like?
Okay, here's Google Cloud Trace Explorer. And hopefully you're familiar with tools like this if you develop cloud applications and run them on scale. And this particular trace is a travel booking agent working with coordinator agent. And as you can see, transferring a task of getting flight information to the flight information agent.
So Vlad, you mentioned the term trace. Would you mind explaining to our audience what does trace means?
Trace is like an end-to-end flow, like a whole transaction. Think about it like a big request that you make to a server, or in this case, to an agent. Traces, they're composed of a bunch of spans. And spans it's like a small subtask, small sub-request. And inside those requests, you have other requests. So they work like, nested dolls, matryoshkas.
Yeah, so to summarize, it's all about making that decision-making process transparent. We hope that helps.
And that's a wrap. We hope now you have a clear understanding of the concepts and patterns behind multi-agent systems.
Thank you for joining us. Remember, all the resources we discuss are linked in the show notes.
Join us for our next episode, where we'll be tackling another critical topic for production agents. Until then, keep your code clean and your agents smart. This is Vlad Kolesnikov
and Shir Lador. Powering down!
The Agent Factory is a Google Cloud tech production. For more in-depth articles, code samples, and links to everything discussed today, visit our Google Cloud community page and subscribe to our YouTube channel or the podcast in your favorite podcast application. Don't forget to check out the detailed show notes for links to relevant agent samples and resources. We'll see you in 2 weeks for your next shift at the Agent Factory.